So, good morning, everyone, and welcome to this lecture. We were dealing with a law of conservation of angular momentum, and in the previous classes, we had done some exciting problems, including the problem from JEE, where we had the mother theorem coming for our rescue, the angular impulse and angular momentum theorem. Then we had our usual questions where the rod was fixed and the bodies were colliding. Okay, once we are done with our JEE mains, then we'll do one more type of question where this rod is not fixed and this rod will move as well as rotate, but the probability of that question coming in JEE advanced is very, very rare, and that will take a lot of time, and that is why I'm not discussing that particular question, because I don't think it can come. And even if it comes, it will be a bit time consuming, and I don't want us to concentrate on that question now. So we will be discussing those questions where the rod can also move later on when we are done with our JEE mains. Okay, so because as I told you, the probability of that question coming is very, very less. So let us concentrate more on the probability, which is more. And I think this was the first question. This was the question that we were discussing in the class. And I told you that now we are not going to deal with impact collision as such. There are not going to be impacts. We are going to be dealing with questions where probably your moment of inertia is changing because some mass being added up or some mass getting subtracted or mass moving away or mass moving towards. So in this category, this is the first question. We had a thin circular ring of mass m and radius r rotating about an axis with a constant angular velocity omega. Four objects each of mass m are kept gently on the opposite end of two perpendicular diameters of the ring. What is the angular velocity of the ring now? Have you done this question?
Yes, sir.
What is the answer then?
Searching for the answer.
Searching for the answer. No, 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 not a good sign. Not a good sign, not a good sign, not a good sign. Chalo, I'll give you a minute in any case.
Sir, it is option A, sir.
Sir, it is option E, sir. And that is the right answer, sir. So how are you supposed to do this? The only thing that you have to understand in this question is that,
I omega 1 equals to I omega 2.
yes, that
I1
is the only thing.
equals to I2 omega 2.
I1 omega 1 is equal to I2 omega 2. There is no collision. There is collision, but not that impact wala collision. Whenever two bodies are kept in contact, whenever two bodies are interacting with each other, they are actually colliding. But here there's not that impact wala collision. They are not impulsive forces there. I1 omega 1. I1 is the moment of inertia of the disk, mr square. I2 is the omega of the disk with the masses, so mr square plus small mr square, small mr square, small mr square, small mr square. So 4 times small mr square, and therefore you have the first option coming in m omega upon capital M plus 4 times small m. Everyone understands this? Yes or no? No, yes? Okay. Comes this one, and I think I had given you an example of this question as well. So let's see if you can manage this one. This is the next question in line. Consider a disk of moment of inertia I1 rotating in a horizontal plane about its axis of symmetry with an angular velocity omega naught. Another disk of moment of inertia I2 is at rest about the disk A. The axis of symmetry coincides. The disk B is released to land on disk A. So what will happen? They will start to slip, and at some point in time, they will start to move with the same angular velocity. Yes or no?
Yes.
When the sliding stops, find the angular velocity of both the disks. Both the disks. So I'll give you 1 minute to note this down. Yes, bacha. Anyone with anything that looks like an answer? I'll give you time, don't worry. So much time? What are we thinking? May I know?
Nothing.
Nothing, sir. Then why is not the answer coming? Okay, I'll give you more time.
Sir, it is I1 omega by I1 plus I2, sir.
It is I1 omega upon I1 plus I2. What took you so long to give me the answer? Huh?
Noting, sir.
What noting, sir? Question noting.
Yes, sir.
Okay, then I can give you. That is correct. Everyone got the same answer? Everyone got the same answer, bacha? How are we supposed to do this? Tell me. Yes,
Same before formula, sir.
same. You just have to do the same thing again, where the whatever is happening between these two discs is happening because of the frictional force. Do you understand this?
Yes, sir.
And since it is because of the frictional force, which is an internal force, whatever work it does on one body, the same work it will do on the other body. So the angular momentum will remain constant. So, wrong color. So basically, I1 into omega 1 initial angular momentum into omega 1 shall be equal to final angular momentum I2 into omega 2. I1 means the first moment of inertia, which is also incidentally I1. So I1 into omega 1 divided by I2 is the moment of inertia of both the disks. So I1 plus I2 into omega 2. Okay, do we understand this? Shall I move on to the next question?
Yes, sir.
Remember, the more the number of questions that you do, the better you are going to become. And I'm only concentrating on the questions that I think can come, have come, likely to come, and not on the questions which will be time consuming and not likely to come. So this is the next one. A circular platform is free to rotate in horizontal plane about a vertical axis about its center. A tortoise is sitting at the edge of the platform. Now the platform is given an angular velocity omega naught. When the tortoise moves along the chord on the platform with a constant velocity. So you can understand, no? This is the type of question that you can find in a JEE Advanced. When the tortoise moves along a chord along the platform with constant velocity with respect to the platform, the angular velocity of omega of the platform will vary. How will it vary? How will it vary? Give you 1 minute to think about it and give me the answer. I hope you understand the question, bacha.
Yes, sir.
So I await your answers then. Remember, every question is a simple one. And I have seen similar questions come. They just check your understanding. How much have you understood the concept? If you understand the concept correctly, bacha, well, voila, you will end with the correct result. Yes, my dear. Anything that looks like an answer?
D, sir.
D, sir. Why, sir? D, sir. So, as he is moving along a chord, so if I can draw a circle here, this looks like a circle. So, this is a disk, and this disk is moving with an angular velocity omega. And this gentleman is walking along a chord. So this tortoise starts from this end and it starts to move like this. So when he is on the edge of the disk, the moment of inertia of the disk is more, yes or no? When
Yes,
it comes towards the center, his moment of inertia of the system will become the least, and then again the moment of inertia would increase. Yes or no?
sir.
So since the moment of inertia is first decreasing and then increasing, omega should first increase and then decrease. Yes or no?
Yes, sir.
So this option goes Bhagwan ke paas. This option goes Bhagwan ke paas. The only two options in contentions are 2 and 4. Yes or no?
Yes,
What is the difference between the second and the fourth one? In the fourth one, you see omega varying linearly. In the second one, you see it is along a curve. Which one will be correct? Will the omega vary linearly? Is the moment of inertia going to change linearly? No, it will not change linearly. Yes or no?
yes,
Yes or no?
yes, sir. R square. Okay.
R square. So it will not going to change linearly.
Yes.
Not going to change linearly, and therefore the answer would be option number 2 and not option number 4. Do we understand this, everyone?
Yes, sir.
Now remember, you might just find the same or similar question in the examination hall. That is why I am doing each and every question very, very precisely. Very, very precisely I am doing it, so that if one of these questions comes, you are ready with your answer. All of these questions are equally likely to come. JEE Main or JEE Advanced. Some questions are likely to come in only JEE Main, and sometimes questions are likely to come. For example, this call wala question. This can come both in your JEE Main as well as your JEE Advanced. So this is the next one. Two disk of moment of inertia I1 and I2 and angular speeds omega 1 and omega 2 are rotating along collinear axis, passing through their center of mass and perpendicular to the plane. If the two are made to rotate together along the same axis, collinear axis, what do you mean by collinear axis? So, collinear means lying on the same line. Do you understand this? So, one disc is rotating ding, 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 ding like this. The other one is rotating probably here, ding, 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 ding like this. So now they are made to rotate together. Do you understand this? So now one disc is put over the top of the other. What is the rotational kinetic energy of the system? Anyone understands this?
Yes, sir.
And I wait for your answers. 2 minutes you shall have. Make the best utilization of those 2 minutes. They have asked you the kinetic energy, not the angular velocity. So remember that.
Sir, it is option C, sir.
It is option C. So quickly you have got the answer. Option C, and option C is correct. How did you get the answer?
So first I have found omega, sir.
Okay, how do you find out omega? Since it is given as collinear axis, remember the axis is same, that means both are rotating in the same sense. Do we understand this?
Yes, sir.
So initial angular momentum and final angular momentum. Remember, this is the same question as that disk rotating and this one disk put on top of it. The only difference is that disk in the first question was not rotating. This disk is rotating here. So how do you need to do this? Question number 4, I think it was, to find out the solution. So it will be I1 omega 1 plus I2 omega 2. Now when the slipping stops, moment of inertia remains same. The angular velocity omega naught changes. Do we understand this?
Yes, sir.
From here you can find out the value of omega naught. Then to find out the kinetic energy of the system, it is only in pure rotation. So half I1 into I2 into omega naught square. That would be the kinetic energy of the system. You can put the values, get the answer, and stay happy. Do we understand this?
Yes, sir.
Well, we are getting warmed up, and now this is the next one. Remember, the category of the problem is same. This problem has come in one of the previous JE, those JEs of my time, which were probably more difficult than this one. That's what I feel. A small uniform rod of length L and mass m has two identical beads of small size each of m, which can freely slide along the rod. Initially, two beads are at the center of the rod. Since this is the same tortoise question, but now they are beads. Are at the center of the rod, and system is rotating with an angular velocity omega naught with an axis perpendicular to the rod and passing to the midpoint of the rod. There are no external forces. When the bead, obviously, when they rotate, the bead go. When the bead reach the end of the rod, what is the angular velocity of the system? You have 2 minutes to give me the answer. I hope we understand this. Yes or no? No, yes? Huh? Simple question. Which are the very simple answer. Trust me on that.
Sir, it is option D, sir.
It is option D, sir. And that is the correct answer, sir. So what you got to do? Same thing, same concept, same answer. Everything remains same, right? When they are at the center, the moment of inertia is ml square by 3. Yes or no? Capital ml square by 3.
Sir,
No,
it
not 3, by 12. It is rotating about the center.
is
Capital ml square by 12 omega naught. When they reach, so it is capital ml square by 12 plus m into l square by 4 multiplied by 2. Yes or no?
Yes, sir.
Do we understand this? Into omega. From here, you can find out the omega of the rod, get your answer, and stay happy. Do we understand this, everyone?
Sir.
Anyone has any doubt? Now I'm seeing this question. Okay, I think we are done with this. We're done with this. Now, can you do this one? This is probably one of the more difficult problems that can come, but if you understand it, it is not at all difficult. Law of conservation of angular momentum we are dealing with. And we have done some fabulous problems here. So, this is the problem. A cube of mass m and edge length L can slide freely on a smooth horizontal floor. Moving on the floor with a velocity v0, it strikes a long obstruction pp of small height. The obstruction is parallel to the leading edge of the cube. The leading edge gets pivoted with the obstruction and the cube starts to rotate. Determine the angular velocity of the cube as soon as the impact. After the impact, you have to find the angular velocity of the cube. You understand the question now? Simple question. Cube is moving, it gets an obstacle, it will rotate. Yes or no? Yes or no?
Sir.
You have to find the angular velocity of the cube. हाँ बच्चा,
Sir, it is root 2 V naught by L, sir.
root 2 V naught by L. How did you get it? Root 2 V naught by L. Huh? How did you get it?
Consider the radius of that cube is
Radius? Huh?
means like diagonal is L root 2, no, sir. And from center of the
What are you doing? First tell me that. I'm getting confused. Diagonal. What is going to happen? First of all, tell me what you have to apply here. Let's start with that point. What do we need to apply here? Yes, tell me that. You have to apply what? Tell me that first. You have to apply what here? Yes, Acha? No idea? Now let me, as a hint, show you these two diagrams. So, this is just before the impact. It comes. And just after the impact, it will start to rotate about this point. Yes or no?
yes,
It will start to rotate. Do we understand this?
yes, sir.
So what you have to apply? What you need to apply here? Just what you need to apply here? Huh? No idea? Roll friend, my dear friend. Whatever forces are acting at this point P. So I have to apply lockme, locam about point P. What is the initial angular momentum? Initial angular momentum, it is moving as a particle. So initial angular momentum is mvl by 2. Yes or no? Yes or no? Huh? Momentum about the point P. It is going to rotate. mvl by 2. Do we understand this?
Yes, sir.
Then the final angular momentum will be moment of inertia about the point P into angular velocity about the point P. So basically this question is just, you just need to find out the moment of inertia of this body, which is a cube, about this point P. That is the entire question. The only question that you have to solve here is to get the value of moment of inertia about the point P. How will you get it? That is the only question. So I'll give you 2 minutes. Tell me how you're going to get it. That is the only question here. I hope you understand this. Yes or no? No, yes. Huh?
Yes.
You have 2 minutes to give me the answer. And stay happy ever after. Yes, my bacha. The only problem is to find out the moment of inertia. As I told you, most of the question in rotation in JEE Main will only come from one topic, and that would be to find out the moment of inertia. Because otherwise, the numericals may become very tough, and you might not have enough time to solve them. Either they will come from moment of inertia, or they will probably come from finding out the kinetic energy or applying locam. These are the only questions that can come in a JEE main. In a JEE main. So you just have to find out the moment of inertia. So this is a revision of whether you know the moment of inertia of this. Do you know the moment of inertia of this? Huh? Sorry. Do you know the moment of inertia of this?
No, sir.
Well, and what are you doing? Are you trying to find out, or are you chilling out? How will you find it out? Do you know how to find it out? I must have to given you enough knowledge that you can find out the moment of inertia of something. Are you confident that you can find it out? Or no? No, sir, I can't find out the moment of inertia of a cube. Then I'll tell you. Obviously, I have not given you that sheet which has the moment of inertia of a cube. I was waiting for the appropriate time so that you can find it out with the logic that I had told you. Moment of inertia of the cube. How do you find the moment of inertia of the cube? So again, I probably have to take a class on moment of inertia. Is that so? Just for that, you can rewind what was moment of inertia. Shall I go back? Go back, go back, go back, go back, go back. To moment of inertia? See, that is what you have to remember, beta. If you keep on forgetting what we have done, it will become very difficult. How are we going to go back every now and then? It won't be possible for us to go do. You forgotten the moment of inertia of a cube. Obviously, I did not tell you how to find out moment of inertia of a cube. I know that. But then I told you that you must know the moment of inertia of everything that is possible. How will you find out the moment of inertia of a cube? See, a small thing, if I don't tell you, you're not able to find it out. That means whatever hard work I'm putting in, if I just don't tell you one small thing, there is no point of taking so much of effort, but because you will not be able to do the question, isn't it? The entire work that we do in the class goes down the drain. Yeah. Anyways, do you know the moment of inertia of a plate?
Yes, sir.
How much is that? Can you remind me?
Its square plate is ml square by 6, sir.
Whenever I ask you moment of inertia, bacha, and moment of inertia is always about an axis. Yes or no?
It is about the axis passing from the center of mass and perpendicular to the plane.
It is how much?
ml square by 6, sir.
ml square by 6. Okay. So just to remind you, if it is a rectangular plate with length L and breadth B, the moment of inertia about this axis will be m by 12 L square plus B square by 12. M into L square plus B square by 12. Do we understand this?
Yes, sir.
What will be the moment of inertia about this axis? What will be the moment of inertia about this axis for a square plate? I mean, for a rectangular plate.
ml square by 3, sir.
M?
L square by 3.
How did you get it?
Parallel axis theorem.
That means you know the moment of inertia about this axis, which passes through the center. How much is this?
ml square by 12.
How did you get this?
And it is from rod, like.
From rod, you know? Because whatever is the moment of inertia about the rod, you don't have to apply parallel axis theorem. It is basically equal to the moment of inertia of the rod about this axis, ml square by 3. What will be the moment of inertia about this axis?
mb square by 3, sir.
Okay. What is the moment of inertia about this axis?
Hmm?
You just said, na? ml square by 12. Yes or no? What is the moment of inertia about this axis?
m square by 12.
mb square by 12. These two axes are perpendicular axes. Therefore, the moment of inertia about this axis becomes the sum of the two. Do we understand this?
Yes, sir.
Pakka?
Yes,
Pakka
sir.
na? How did you get the moment of inertia of this plate? By using the moment of inertia of
Rod, sir.
pakka na? So how will you get the moment of inertia of this cuboid? How will you get the moment of inertia of this cuboid? By using the moment of inertia of what? Plate, which is same as the moment of inertia of the rod. Yes or no?
Yes, sir.
So this is the moment of inertia of a cuboid. If you take axis number 1, which is this axis, so you have to see which are the two sides which are coming there, and it is m by 12 into L square plus that side square. Yes or no? Because it is made up of plates put like this. Do we understand this?
Yes, sir.
Moment of inertia about this axis will be moment of inertia of this plate. All these plates are put together like this. Moment of inertia about this axis will be all these plates put together. Yes or no? And that is how you get the moment of inertia of a cube. For a cube, all of these are equal. So for a cube, about any axis, 1, 2, or 3, the moment of inertia would be m L square by 6. Do we understand this?
Yes, sir.
Write it down now. Write down this cuboid. Draw the diagram, write it down so that you don't forget. So moment of inertia will be ml square by 6. Once you understand this, then you can come here on this question, because then only you are going to solve this question. If you are not able to find out the moment of inertia, even if you know how to do this question, you will not be able to do this because you are just not able to find out the moment of inertia. Now, can you solve this question? Everyone understood this, what I am saying? Okay. Chalo then. Note this down and then I'll give you 1 minute. Once you note it down, let me know. Then you can go back to the question. So, Bacha, let me now come back to the question. And can you now give me the answer for this question?
Is 3V by 4L, sir.
3V by 4L. That is absolutely correct. Now, you must understand that the entire question just depended on two simple things. The first simple thing was law of conservation of angular momentum, because whenever there is an impact, gravitational force and all those forces cannot do anything special. What does anything special is the impact force. The impact is coming at the point P, so the angular momentum is conserved about the point P. Initial angular momentum, final angular momentum, and you are done. Initial angular momentum is so simple. Final angular momentum is also simple if you understand to find out the moment of inertia of the cube about this edge. That's it. So what is the moment of inertia of this coming as? About this central axis, it is ml square by 6. Yes or no?
Yes, sir.
Then about this axis, what you have to find out is the length of this line. This is L by 2. This is L by 2. So plus m into this length ka square. So it will be L square by 4 plus L square by 4. Hypotenuse. This is the hypotenuse. Yes or no?
Yes, sir.
into omega. So remember this. This is probably not a question of law of conservation of momentum, but these type of questions are very famous with JEE, where they miss two or three concepts. The two concept mix law of conservation of momentum and whether you know the moment of inertia about this axis. So please keep such questions in mind. Do we understand this?
Yes, sir.
Confident
Yes, sir.
or not? What about the sheet? Have you done questions on the sheet that I had given? How far you have come on the sheet?
Sir, just now completed circular motion, sir.
Circular motion in the sheet. You have not done any question on rotational sheet. I'm talking about the rotation wala sheet.
Not yet started.
Wow, I'm so happy. So when are you going to start it? When is the Shubh Muhurat? And we are going to start. We are doing rotation, and you are not solving question on rotation. You are doing circular motion. That is obviously not good.
I am completing sheet-wise sheet, sir. First, I have completed units and then motion in 1D, 2D, NLM, like that. I am completing one by one.
Okay, okay, chalo. Okay, I'm looking at this. And let me do this question. All these questions. I'm giving it from the sheet so that you can have a lot of practice on this, because I expect that these questions can come. So this one, simple question, and these are the questions that are going to come. This one. Tell me the answer for this one. A thin circular ring of mass m and radius r is rotating about an axis with a constant angular velocity omega. Two objects each of mass m are attached gently to the opposite end of the diameter. What is the angular velocity of ring? Yes. Can you do this? I'll give you time.
Sir, it is option B, sir.
It is option B, sir. How did you get the answer, sir?
Sir, I1 omega 1 equals to I2 omega 2.
You just have to apply I1 omega 1 is equal to I2 omega 2, and you get your answer. Everyone understands this, yes or no? Shall I do it, or you are able to do this?
We are able
Understand
to
this?
do- Yes, sir.
See, everything is on the same concept. The concept never changes. The concept remains the same. Let me. This one. Question of JEE Advanced. Multiple choice.
B.
Everyone got the answer for that one? I moved on. Shall I move on?
Yes.
This one. A thin rod of mass m and length L is hinged to the ceiling and is free to rotate. A particle of mass m moving with speed v strikes it as shown in the figure and sticks with the rod. The value of v for which the rod becomes horizontal after collision. I hope you understand the question. Which option is correct? Need to give the correct option A, B, C, and D. Do you understand the question? Yes or no?
Yes, sir.
Let's see if we can do this. Okay. So out of C and D, which option is correct? You can say that it's a multiple choice question. So out of A and B, one option is correct probably. And out of C and D, one option is correct. Yes or no? Which option is correct from C and D?
C, sir.
Which option?
C, sir.
C, sir. It will remain constant about the hinge. Remember, whenever you encounter a question in JEE Advanced, that is a multiple choice question. That is a question that is going to give you the most negative marks. So only answer those parts which you are sure about. If you're sure about part C, then just mark C. And if you're not able to do the rest of the question, forget about it, move to the next one. Do we understand what I'm saying? Now, the rod has to become horizontal after collision. I had done a question where I'd asked you the height of the rod. Yes or no?
Yes, sir.
This is a different type of question likely to come in JEE. This is how the frames question in a JEE. And when I say JEE, I mean JEE Advanced. I'll give you time to solve. This is a JEE Advanced question. See what I was telling you? I've got something to tell you. I hope you are trying the question, yes or no?
Yes, sir.
I'll tell you a question from last year JEE Main. I think this is JEE Main of 21. And see this question. See what I was telling you? Do you see this question? And I put it just on the top of the question that we just did. This is a question taken from JEE of 2021. And this is a question that we did in the class. And I told you, I just now opened the previous year papers. So, what is the moral of the story? If you just do questions which I have sent you and which I am doing in the class, the same question will land up in your paper. Same, na? Even the language is same. They have not even changed the language. Have they even changed the language? They have not even changed the language. They have not even changed the language of the question. Because they will not do that. Yes. Can I do it?
1 minute.
Okay. So, what is the first thing that you need to do? The first thing that we need to do is apply what? You have to apply law of conservation of angular momentum about the point O. Initial angular momentum is equal to final angular momentum. The question that we did, the bullet was falling perpendicularly. It is not falling perpendicularly, so you'll have to resolve the velocity along two directions. Yes or no?
Sir, it is option A, sir.
It is option A, 168 by 9. Well done. Correct. This is the correct answer, 168 by 9. Good. Yes, so I have to apply locem about the point O. How do you apply locem by the point O? You have to find out the initial angular momentum. Initial angular momentum is m v into L by 2 into cos of 60. Yes or no? So cos of 60 is half. You can find out this this component of velocity. That will be v cos 60. Yes or no?
Yes, sir.
So mv into L by 2 into 1 by 2. That is the initial angular momentum and it sticks to it. So final angular momentum becomes ml square by 3, both the masses are same, plus m into l square by 4 into omega. From here you can find out the value of omega. What is the value of omega coming?
Sir, I have done it in reverse way, sir. Like I have first taken rod at highest point and then
But
lowest.
you will get the value of omega, yes or no, somewhere?
Sir, it is 24 by 7L, sir. Under
No,
root 24 by 7L.
no, it cannot be root 24 by 7l. At the lowest point, omega cannot be root 24 by 7l. It will be 3 by 7 v by l. Cannot be root over 24. Okay, so this will be omega. It rotates. It will reach at the highest point. At the highest point, the total energy is potential energy. At the lowest point, the total energy is kinetic energy. Yes or no? So then you apply what? Then you apply law of conservation of mechanical energy. From which point to which point? From the lowest point to or lowest point A to the highest point B. Yes or no?
Yes, sir.
At the lowest point, you have kinetic energy half into I. I is same. I think it is 7 by 4. 7 by 12, right? 7 by 12 ml square into omega. Omega is 3 by 7 v by l. We have already calculated it. Yes or no? Into omega square, half I omega square. Do we get this? That should be equal to, when they come to the height, you have to find out what is the change in potential energy. At the lowest point, you can take the gravitational potential energy as 0. Do we understand this?
Yes, sir.
This rod center of mass had moved the distance L by 2. This bullet has also moved the distance L by 2. So the change in potential energy will be, or the potential energy will be 2 mg into L by 2. Yes or no?
Yes.
You put these values, you get the answer. And from there, you can find out the value of V. And the value of V is coming as 168 by 9 root over 168 by 9 G by L. Same question I did, but this is the different variation of the same question. Do we understand this?
Yes, sir.
Now look at this one. Same question we did in class. And you can see the same question coming in your JEE of 2021. I'm taking all these questions from previous year papers. Taking all these questions from previous year papers. You can check them. This is 21 ka JEE. See, I was shouting so much on you about the moment of inertia of the square plate. Remember, this was the question from again 2021 JEE. And remember, I told you one short trick, right? If they give you one question from one topic in one session, they will always give you what? In all the session. Did I tell you this or not?
Yes, sir.
Same, same. Moment of inertia of a square plate of length L about an axis path. You can find it out, yes or no? These are the questions that they ask in JEE Main. You can find it out, yes or no? Tell me the
Yes,
answer of
sir.
this one. You can do it now.
Yes, sir.
These are the questions from JEE Mains, beta. You can see how simple they are.
It is option 4, sir.
Oh, good. See, you can do them orally. Well done. This one, JEE 21. Yes. Yes, what is the answer? You don't have to think. It remains same in magnitude and in direction. It does not change.
Sir, I'm thinking that axial vector and direction
A single particle. It's a single particle moving. Dung 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 dung. It's not conical pendulum. Dung 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 dung. What will change? Nothing will change.
calculate that direction, sir. It will
What direction, sir? All these are oral questions, sir. What direction, sir? What do you think what direction, sir? See, in this question, they are asking you the moment of inertia of this solid cylinder about this point. You cannot do this. Eh? See what I keep on telling you. The only thing is this question has what? This question has values. You just have to use it. So solid cylinder, the same moment of inertia as disk, mr square by 2 plus ml square. You are done. Yes or no? No, yes. Huh?
yes.
See, all these are oral questions. Do we get this? Yes or no?
Yes, sir.
See, moment of inertia of a badminton racket, you cannot find it out. Huh? This is JEE. Find it out or not?
Yes, sir. We can find it.
See, see, sometimes I feel very. See, I had given an entire class on discussing this, yes or no, and I did not know that this question has already come. This came in the year 2021, JEE Advanced. See, this is the conical pendulum. I told you, na, dung 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 dung. Did I tell you that or not?
Yes, sir.
That is the dung 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 dung. Remember the dung 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 dung. See, so what is the moral of the story? If you just do what I do in the class, keep on doing it correctly, just listen to what I am doing. I tell you everything that is possible. See, this one. Remember this? Same question comes in the JEE, and it will come because there is nothing that I have not told you that cannot come. That that can come. There's nothing that is there to know. I've told you every damn thing that you should know. Everything. But the only thing is, if you practice enough and you remember those things that I had done in the class, you would do exceedingly well, whether it is JEE Main or it is JEE Advanced. I'm giving you all these questions from just a previous year JEE. See, I just now got this sheet. I just made this sheet just now. See, on last Sunday. See, JEE Main 2021. We have done the same question, right, in the class? And I had no idea that this question has already come. See, this is your JEE. This is your JEE. I put one more question behind this. See, this is the question of a JEE. Anyone just with simple, you don't have to even use your copy and pen. You can do it without your copy and pen, right? So just concentrate on what we are doing in the class and just do the sheet that I have sent you. It is much more than enough that we'll need to do anything. We are done with your angular momentum. We are done with your thing. Now the other type of question that are going to come is on plane motion, but we'll be only restricting ourselves to the sort of questions that are more likely to come rather than just see. As I told you, rotation is infinite. I can teach you rotation for one full year, and again I will still not be finished with rotation. So again, looking at what is coming these days, what can come, I will start with your most difficult part of rotation, and that is body will rotate and body will also move. Up till now, one body was rotating and the other body was moving. Now this body will also rotate and will also move. Do we understand this?
Yes.
So take care and I'll see you on the other side of this week on Monday, and we will try to wind up that part as soon as possible. Okay? Take care. Have a nice day. God bless you all. Bye bye.
Thank you,